I like IoT, but there are some problems.
Well, one of the problems, and it's massive, is there is this proliferation of devices that are out there generating data, but they can't connect to the internet.
That's exactly right. We need something like IoT Edge, and that's what we're going to talk about on this episode of DevRadio. Hey, and welcome to the next episode of Microsoft Dev Radio. I'm Jerry.
I'm Darren.
Hey, Darren. And we've got Olivier on the line. Who's Olivier?
Let's ask him.
Olivier, who are you?
Hey guys, thanks for having me first. Who am I? Actually, I'm a PM in the Azure IoT team, and I look after our technical communities. I've been at Microsoft for something like 13 years almost now. First as a developer advocate, and then as a PM for features on the Azure IoT team. Prior to that, I've been a developer in the embedded space. I've been developing real-time systems, so kind of the premises of IoT devices. And yes, I've been having fun with IoT technologies for a very long time now.
All right, let's start with definitions of what things are. So an IoT device is a temperature sensor an IoT device?
Anything that has some computing in it that actually is not a computer is an IoT device.
A laptop is not an IoT device.
I do not consider a laptop as an IoT device. A laptop can contribute in an IoT application or scenario, but it's a laptop, right? So it's a PC, a personal computing. And actually, the definition of a laptop is that basically you have a human in front of it. The other devices that we are talking about in the Internet of Things is that you don't need to have a human controller or operator. Some of these devices might be controlled by humans, but they have a level of autonomy or a level of capturing of the sensor data and so on that are around the device itself that are automatic or that they're a part of the device itself. The laptop needs a human to function and to work, right? It serves a purpose.
That's a great point.
The interaction of the human.
That's right. And I guess a very small laptop would be like a Raspberry Pi. It could be a device. I suppose it could be a gateway as well. So it could be a little bit of everything.
Yeah, the Pi is an interesting example. Like lots of people, especially in the embedded space, to say that, hey, Raspberry Pi is not an IoT device or an embedded device because it's actually a PC. So some of the arguments in that direction actually make sense. And you can, though, configure your Raspberry Pi as an IoT device. Put some sensors, make it headless, connect it, shares its sensors information up to the cloud, participate in an IoT application, eventually run compute at the edge. And so something we're going to dive into because that's a level of smartness, I would say, or intelligence that other IoT devices might not have that allows the Pi to run some level of intelligence down there at the edge.
Let's see, what's the last smart device you plugged in?
Last smart device I plugged in was actually a hybrid. So it's the Dragon board 410C. You're familiar with that one? So it was running a Windows 10 IoT core.
Wow.
So that's actually the last one. I actually still have it in a bag somewhere.
Wow. The last one I got was, what's the port in your car? ODP, is that right? OPD? Yeah, I just plugged one in there, and it has a built-in 3G transmitter and everything. It's incredible. I can ask Alexa where my car is at any moment.
And really your insurance company knows as well, by the way.
Yeah, probably a lot of people know now. That's right. What's the last smart device you plugged in?
So on the consumer side of things, I've been playing around with the Harman Kardon speaker, the Cortana one.
Really?
These are pretty sleek, but these are the high end, I would say, of what you would expect an IoT device to look like it to be. Otherwise, I'm playing regularly with tons of microcontrollers. These are like smaller ones. Could we just mention some of these higher end devices or bigger ones, like the Harman Kardon is a good example, the Dragon board as well, the Raspberry Pi? All of these can be considered, PC class or big gateways type of devices. They don't represent the big chunk of what the billions of IT devices are when we talk about these numbers. We talk about, like I don't remember the exact number, but it's like a huge amount of device that will be connected by 2020. And
Gazillions. I think
gazillions.
I
That's
read
the
that
technical
article.
term, yeah.
Yeah.
I read that article. Yeah.
But there's an interesting data, which is today there are already billions of microcontroller produced every year. And these are mostly, for most of them, not connected yet. So they don't contribute or participate in an IoT application per se, but they are connectable. So that means that there's a huge opportunity for devices that are smaller, that are microcontroller with a few sensors on them, running on battery, sometimes, like in the dirt for 10 years, running on that battery,
Cost
which is
15
yeah,
cents.
exactly. And this is actually what is the interesting part of the IoT story. The bigger ones will be the controller, will be the PLCs, will be the devices that might be a gateway to the other ones. The other ones are actually what we're looking at with big eyes saying, wow, that's a huge opportunity from the business perspective here.
I was working with a company in Norway that all of their devices were underwater. I mean, it's crazy what we put these devices through. The heat, the wet, totally remote, freezing cold, terribly hot.
Yeah, and there's one aspect to them, which is they are physically resilient to these environments, but there's another aspect to it. They cannot fail. You cannot have one of these devices, that is underwater or under the dirt for 10, 20 years that fails, because you cannot send a human to go, put a USB stick and update the firmware or
Press
whatnot.
Control-Alt-Delete on it.
Yeah.
Exactly. And this is the big difference between these bigger boxes that run a Linux operating system or a Windows one that are not real time. These operating systems are more operational and they're bigger. If you want to be, able to run something for 10 years that will be resilient to a lot of things and conditions, you need to run a real-time operating systems on a microcontroller that actually will be deterministic in its way of working and running. And this is like a different world than the one that we know in the cloud, in services, or in PCs.
That's right. So on one side of the game is these tiny little devices that talk to Azure all the time. Right? They're always connected, and I always know where my car is, as an example, right?
Yep.
But that's not really the mass of the other side, right? Where it is, you're at an oil rig, or maybe you are underwater, or maybe you're in just a very remote location, and you have to do all of these pieces. And that's really where what we're talking about today. IoT Edge kind of plays into this to give opportunity for these scenarios. So we know what IoT is. We were just kind of playing on what the definition of those things were. But talk to us about IoT Edge. Just kind of introduce it to us, and then let's go at it.
Cool. So you just mentioned a couple of very interesting scenarios. So we want to connect these devices. We want to connect these billions or gazillions of devices to produce data. And the main reason why we want to do that, because we want to extract insights from these data coming from devices and take action on them, right? However, we cannot always do that for the reasons. Some of the reasons are the ones you mentioned, like these infrastructure might be remote. They might be in positions where connectivity is not good, or they might be in a place where they're connected, but eventually transferring data is super expensive. Or it becomes expensive at an IoT scale. When you send data from your Raspberry Pi for your temperature, in your home wine cellar or something, that's fine. You can send data every 2 seconds. That's okay. But you do that at the scale of an actual service where you have millions of the devices. Well, you cannot afford to pay the freaking bill to the ISP or to satellite, companies. So you need to think about a way to store and eventually start doing a level of analytics on that data on site, on premise. Another reason why you want to start doing that is privacy. Think about a scenario such as a retail shop. You have a store where you have people coming in. Eventually, you want to put cameras to do some analytics on people's behavior. Are the aisles full or empty, whatnot? Well, people might not be super happy with having their image taken and used somewhere or eventually stored in a public cloud somewhere, right? So you are able to do, thanks to technologies like IoT Edge, a level of processing on-premise as close as possible to the source, to the IoT devices.
Yeah.
Azure IoT Edge is a technology that allows exactly that. It allows to run workloads from the cloud and trained in the cloud as close as possible to the IoT devices to address these scenarios, whether they're not connected, whether you want to have the data stay on-premise, or sometimes in some of the systems we're going to have a very short loop with no delays in a response to a problem. If you have a robot arm that is actually sending tons of data, you detect an anomaly and you want to stop the robot arm before something breaks. You want to do that without having the back and forth to the cloud, where yes, it can be milliseconds, best case scenario, but then it can be seconds in worst case scenario, because you go through gateways and routers and whatever.
That's right.
And so you want to react.
Because the speed of light is still the speed of light.
Exactly.
So
yeah, you can only go so fast. That's right.
Exactly.
I had another partner we were working with, and it was ML they were needed to process on a active drone. And as it was approaching, it would decide what to do depending on the landscape. Man, you cannot send that up to Azure, let it process it, and bring it back down.
Pull up. Oh, too late.
Exactly. So what we did actually, when we started creating the Azure IoT services, 4 or 5 years ago, we started with an infrastructure. Here is a gateway in the cloud called IoT Hub that allows you to connect devices securely and have a bidirectional communication. And we evolved these services, added some more in the back to do the analytics, and then eventually to do the visualization of that data. And we also packaged all of that in the form of a SaaS offering called IoT Central. But at the same time, we looked at these customers asking for, hey, I don't want all the data to go up. What can I do to run my analytics at the edge? And so we created Azure IoT Edge as a runtime that runs on Windows or Linux. It's based on Docker containers, and it allows to configure from Azure these devices, telling them what kind of workloads they need to run. So the IoT Edge runtime boots when the device boots, connects to IoT Hub, retrieves a configuration, downloads the containers it needs to run. The runtime itself will guarantee, the good health of these modules, will also enable a communication in between these modules, and then we'll establish that logic that is on premise. And then the device can become autonomous, and it can be attached to other IoT devices itself, right? So basically you can create a gateway or a controller that has several leaf devices connected to it. And this guy now can, running IoT Edge, it can orchestrate a communication between these leaf devices. It can implement some analytics, machine learning. It can leverage Azure Functions, Stream Analytics, bunch of other things.
Okay. Wait, there's so much going on here. Hey, all right, let's back up, because there's a lot. I mean, IoT Edge, God, there's a freaking lot to it. So it can run on Linux or Windows. Has it always been able to run on Windows?
It has always been able to run on Windows. It's a runtime that's been developed using .NET Core. So and that was the main reason for using .NET Core, was to be able to run on several platforms. And we'll talk about that later as well. We use this notion of platform for Windows as a host, for Linux as a host, and then we now can use Kubernetes as a host as well for IoT Edge. So it's going to be an interesting discussion after. But so IoT Edge has been able to run on these various OSs from the get-go, because they address scenarios of existing infrastructure and devices. And now the market of these gateways or PLCs is kind of a share between Windows and Linux. Big market share for Linux, but also big customers using Windows on these devices, on these smart devices. A very good example.
So IoT Edge works a little bit like Kubernetes, actually, right? In a little bit like an orchestrator, but definitely a container service. And if I run the SDK inside my container, I would use .NET, right? .NET Core, and then I can tap into a pipeline to allow me to string these containers together inside IoT Edge.
Yeah, so I would not call IoT Edge an orchestrator. Maybe at the scale of the device itself, yes. But Kubernetes is so much powerful in terms of allowing you to create clusters of devices and manage resiliency, and eventually having several instances of the same machine that can eventually load balance and so forth. IoT Edge doesn't do that and is not meant for that. IoT Edge is really, you can call that a mini orchestrator at the device level.
Because it keeps the containers alive. That's the mini one, I guess.
That's pretty much it. It keeps
and it also sort of facilitates that communication between those containers.
Yeah, it establishes that communication in between containers. It doesn't prevent you from leveraging the Docker functionalities and features as well. If you want to open ports into your container images and have these containers communicate over HTTP directly without going through the IoT Edge infrastructure, you can. IoT Edge guarantees a level of encryption and security, though, so you might want to actually use the IoT Edge pipeline for that. But IoT Edge is really and very much more at the device level. If you combine with IoT Hub in the cloud, which is our device gateway in the cloud, you can establish also a level of communication in between edge devices through IoT Hub, right? And IoT Hub starts working as a router for data to go from one device to another one. But then if you think about Kubernetes and the orchestrator scenario for containers, Kubernetes is very much more about leveraging the functionality around clusterization and resiliency and so forth.
Yeah, that's right.
And actually, they are very complementary. You can think of IoT Edge as being, your engine for running cloud workloads at the edge and managing them from the cloud. And then you can use Kubernetes to create cluster of IoT Edge devices. And for example, if you need to have something that allows for high availability, redundancy of a specific critical machine running IoT Edge, you can use Kubernetes for that. And Kubernetes will work perfectly with IoT Edge, where you say, I want to create a cluster, 2 devices with nodes and all the shebang that Kubernetes offers, and I want IoT Edge to be actually running on them. And you can do that, and you can control this cluster through IoT Hub transparently. Kubernetes manages the cluster aspect of it. IoT Hub manages the which workloads need to be run on which IoT Edge devices.
Now, I think that's an important thing to point out as well, that I have IoT Edge, and a normal situation for a company is probably they have more than one. They probably have them spread out across stores or across manufacturing facilities or whatever they have, wind farms. And they're not managed there. They're managed in Azure if you want them to be, right? You can have this to be a very centralized, simplified experience.
Yes, totally. You can. However, IoT Edge has an interesting feature that is coming up soon. We already started enabling that, which is the ability to run IoT Edge offline. So the typical way IoT Edge works is that the runtime, which is a little bootstrap, starts. It actually connects to IoT Hub, retrieves a configuration telling it which container to download and how to orchestrate communication and route messages. So it does that, downloads the containers, runs them locally, and then routes the messages from one to another one. Once you've been doing that first configuration, you can run offline. The IoT Edge runtime does not need to ping home on Azure in order to run. It can just be totally autonomous independently. You have some modules, though, that have a billing mechanism to it, and we can talk about that a bit more. Where we have
like cognitive services and containers have a little bit of things like that.
So we have the first-party ones and Microsoft ones, but we also have an ecosystem of partners developing IP, containerizing that, and selling that on the marketplace, on the Azure marketplace, so that companies can leverage, these kind of pre-built modules for IoT Edge and just leverage them. So in these kind of scenarios, you need to have a ping home to the marketplace to indicate that there's consumption, right? But if you're in a scenario where you use your own modules or modules that don't need to do that, you can run totally offline. And soon we're going to have another feature that will allow you to configure an edge device fully offline as well. So you can imagine a situation where, say, that device, I want it to run anomaly detection, and I don't have a network connectivity, so I can actually do a local configuration with my local containers or on-premise, right? You can be on your own infrastructure, not connected to the internet, and you can have a deployment of IoT Edge on a device doing locally. So that's
now here. It's time to let's blow our minds here. Tell us how much IoT Edge costs, because I think that's an important thing for developers and everybody to understand.
Yeah, so IoT Edge is free and open source. So it's actually available under an MIT license on GitHub, and it's totally free to run. So you don't need to pay for IoT Edge runtime itself.
So I'm the Department of Defense, and now I can review all the code and go through my security audit that I need to. I can start to use it and not worry about licensing, and I can have it all offline behind the firewall as well. And all of a sudden, I've solved a million problems that I had before and couldn't solve. And I have the same thing if I'm an oil company. I have the same thing if I'm a whatever, and I have the same sorts of constraints that I need to go through. I mean, it's a pretty sweet thing. I mean, that's the one. As we talk about how awesome it is, we have to interrupt and say, but we're not going to it's free. Like it's hard to believe really that it is, to be honest.
Well, so much the value is in the scenarios it facilitates, isn't it?
Totally. So the scenarios it facilitates, and also the interest of running IoT Edge versus just running a plain OS with your own software is that you have, once you have IoT Edge runtime, you have a way to update and monitor from the cloud how these workloads are evolving on that device. So the offline scenario is important. Like the cruise ship is a good example. Like these big used cruise ship, now they have all these IoT devices on board for consumers, but also for all the what's happening in the back. Once they are away when they are offshore, they don't have a network connection besides satellites, which is super expensive. Right. So they have several ways of doing that, and depending on the size of that cruise ship, they can go all the way up to Azure Stack, where you have a full Azure on the boat, down to IoT Edge, where you have a smaller version that runs your workloads. But then when you're getting back to the coast and you have connectivity, you might want to eventually evolve your models that you've been training in the cloud based on data coming from several cruise ships. You might want to update them. You might want to, add functionality and so forth. And you do that at the scale of a cruise company. So it's not just one ship, it's several. And so you want to be able to control that in a centralized way. And then you want to leverage the services that can be developed in the cloud and trained in the cloud. Machine learning is not something that you do based on data from one device, at least not these very evolved models. You need to train them based on a lot of data, and you can only do that in the cloud efficiently. So the value is very much in the scenarios and also in these workloads you're going to develop and train in the cloud and run at the edge.
Now, IoT Edge, this is another important part I think that you want to understand when you invest in IoT Edge for free. The type of machine we expect you to install that on is not necessarily the largest server you can buy.
No, and the thing is, actually, this is where the embedded developer in me actually is happy, because IoT Edge is not small, but it's not big, but it also will require hardware depending on the software you're going to run on that. So if you just want to run a very simple module that does a threshold check on temperature data, you can run that on a very tiny device that barely runs Linux, right, and Docker, because these are the basic requirements. And then on top of that, you add a few megs for your own code and runtimes and whatever, and you can run very tiny devices. The day you want to start doing vision, machine learning type of algorithms and so on, you need to have hardware that's going to be beefy enough to do that analytics on that huge amount of data or complex types of analytics. So typically, DataBox Edge is a good example of a product that leverages the latest in FPGA technologies to do inference on images. And so you can have IoT Edge as the runtime on these very beefy servers, machines, to do these kind of processes. So the good thing is that you don't need to buy a big server to do something simple, but you can actually grow the IoT Edge runtime and its features and capabilities to whatever your scenarios or needs.
It just depends on what you're asking it to do. IoT Edge,
exactly.
What you're asking it to do might require
simple routing of messages, easy.
Yeah, that's exactly right.
Want to process frames of video streaming real time? Not so easy. You need a bigger box.
Exactly.
Yeah, that's right.
Exactly. And there's going to be, side projects that are very interesting as well that allows us to run machine learning on microcontrollers. IoT Edge being one part of the story. When it comes to running intelligence at the edge, IoT Edge is really addressing these mid-size to bigger size, devices. The smaller one, you will think about tooling and runtimes that will allow you to compile models that are developed in machine learning on Azure controller and compile them for microcontrollers directly. There's a very cool open source project called ELL that Microsoft Research has been developing. There's also work going on Azure Sphere and other platforms that do not support IoT Edge because they're smaller, that will allow to run machine learning. And the interesting thing is that the same models trained with like the same data can then scale to smaller devices if you want to analyze just, or maybe recognize, 10 words on the tiny microcontroller devices. There's a good example of L doing that, where you can do that, 10 words, that's all you need. You can run on microcontroller. The same model, the same neural network model can be trained to recognize 2,000 words, and it's going to run on top of IoT Edge with an actual machine learning module on an IoT Edge device. And then you can go with like millions of words that the same algorithm could be recognizing on very beefy server machine with tons of storage and FPGAs and so on.
Of course, there's also all of this work being done on custom silicon for AI as well.
Totally, right. Like the custom silicon in various places and various levels. Actually, Google has a very interesting technology called Edge TPU, which is about actually special silicon for microcontrollers to run machine learning algorithms. The L project is a good example of how you can have software compiling for specialized hardware as well, where you can actually customize the compilers for that hardware. The FPGAs of Project Brainwave are super interesting as well. They've been designed for the cloud. They run on DataBox Edge today on premise on devices powered by IoT Edge. So that's a very interesting realm that actually is very broad. And as you were saying, like the tasks you need that hardware to do will define what kind of hardware you really need. And then the cost of it, right? You can have a $10 board or even less that will recognize your voice and certain amount of words. Right. And then you can go with something which is like thousands, times more expensive that will do, better job at recognizing more words and so forth.
Let's talk about the capabilities of IoT Edge for a second. So I have IoT Edge sitting at the barrier of my my network, let's say, right? Yeah. And it's talking to Azure, and I'm managing it from Azure, and maybe I've got a whole bunch, I don't know. But the next question is, I want to have IoT Edge as a child of IoT Edge. I want to have the Leaf B IoT Edge. Yeah. That's a capability that we've talked about. What's the status today?
So this is still in development. The hierarchy of IoT Edge devices, being able to actually nest them and put them on top of each other, is something that's not available yet. We are still, considering the feature itself.
Sure.
The meshing of IoT Edge devices is as well interesting. It's not just about piling them up. It's eventually about having them, working as a mesh and allowing to have cross IoT Edge devices communication offline eventually. So these are all scenarios we're looking into. There's no announcements, no preview or whatnot about these that are available, but feedback is more than welcome, in terms of, hey, we'd like that feature, whatever. We have user voice entries for that, and that we're listening for some information from customers, from users. The other thing is the IoT Hub story is important as well, because you have the notion of Edge being at the edge, but then IoT Hub, today works as a gateway for devices. There's been asks to have it work more as a broker for communication between devices, because today what you have to do if you want to establish a device-to-device communication, you have to retrieve information in the back end, have an intelligence. It could be as simple as an Azure function that gets the messages and sends them back to another device. But IoT Hub itself doesn't work as a broker yet. So these are things that we're looking at and considering to implement or enable all these scenarios that IoT are.
Yeah, I can see all three of those being awesome.
Yeah, I mean, now, sort of your primary sort of communication, correct me if I'm wrong, back to your devices is kind of through device twin updates.
So you actually have three ways today of communicating from the cloud to devices. One is what we call the cloud to device messages. So that's the equivalent of the telemetry that goes from device to cloud. This is a raw message that you can customize at will. Then you have something which is the device twin update, device twin being that notion of state management from the cloud to synchronize the state between a device and its device twin, its shadow in the cloud. And the device twin property property, the desired property is synchronized, and that's one way of setting up a property or a configuration on the device. So there's that notion. And there's a last one, which is a more synchronous way of sending a message to a device. It's called a direct method. Mm-hmm. And think of it as a remote processor call on a device. You call a function from the cloud through IoT Hub. You say, I want to run that function on that device, and here's my timeout. And you're expecting an answer from the device through IoT Hub. So you have these three ways. So the device to cloud, which is raw messaging, the twin, which is an asynchronous state like synchronization, and then the direct method, which is synchronous procedure call from the cloud to the device.
And IoT Edge isn't required for all three of those to necessarily work. At the SDK on the device, that's important.
Correct. So the device itself doesn't need to run IoT Edge. IoT Edge would be a gateway eventually in between, if need be, or IoT Edge also can enable devices that are not connected to the internet to actually access IoT Hub or the web, right? But you don't need IoT Edge to establish the communication to the devices and from the devices, unless these devices are not connected to the internet.
Right, that's the scenario where IoT Edge is important.
That's kind of bridging the protocols, as it were, because, IoT Hub supports a bunch of protocols, but you might have sensors and devices that have their own bespoke protocols, and you need some sort of bridge that sits in between those and the hub itself.
And it's an important thing when we have a device that's talking to IoT Edge. We have a provisioning protocol already figured out. Like all of this is in place to make developers' lives easy, especially around provisioning, which could be really tricky.
Yeah, so you're totally right. I think the interesting thing I was saying at the beginning is that the interesting part of IoT is there's billions of devices that are not connected today, and they're not connected to the internet, but they are connected like on specific buses or field buses, such as BACnet for building automation, or CAN for cars, and there's tons of other Modbus, and I could go on and on with these protocols that are actually used in the field. And you can very easily, thanks to IoT Edge, bridge these devices and these networks with these protocols to the internet and to the cloud. And as a matter of fact, there is already a collection of modules that would do protocol translation on IoT Edge. And we have a marketplace, the Azure Marketplace, that has an IoT section. And in the IoT section, you will find the IoT Edge modules that we or our partners are producing. So if you want to connect your Modbus infrastructure to Azure, you don't need to redevelop your own module to transform or translate that protocol. You can just leverage an existing module. So that's very important. To the notion of provisioning, same thing, IoT Edge will allow you to make these devices contribute to an IoT application that is secure, where devices are authenticated, where they are provisioned when they're coming out of the box. And IoT Edge will facilitate all that through IoT Hub and the device provisioning service as well.
And if your company wants to use certificates in order to authenticate that provisioning, fine. We can. That's what we want you to do, frankly.
Totally. And I think we in the IoT team within Azure, we like to give options. And so basically, and the main reason is because not all customers are working the same way. So yes, certificates is one way. You can have self-signed, you can have CA-signed certificates.
You could have wide open, unsecured.
You can't. No. Actually, we will not allow that.
When you got HTTPS, symmetric key.
Yeah, that's correct. Right. Yeah, so you can use symmetric key for the authentication as well. In terms of encryption, we enforce SSL, so HTTPS. So there's no choice. If you want to connect to IoT Hub, you have to go through that. And then, like security, I think is a topic which is very important. IoT Edge adds the level of security in terms of authentication. And encryption of data, but we're also looking at other scenarios. So IoT Edge devices are devices that eventually can support what we call the hardware secure modules, like TPMs, DICE, and others. These are very powerful chips that will allow you to do two things. One is safely store critical information. So you can have a password or a key that is stored within these chips. The second one is to eventually run a little algorithm that you don't want anyone to see. It could be an encryption algorithm. It could be something that actually is running in a safe environment. And we're looking at having IoT Edge running on top of something we call a secure enclave, which is a tiny runtime that would sit below an OS and that will implement a logic within a hardware secure module that IoT Edge can work with. So the runtime IoT Edge would allow your modules and eventually leaf devices to leverage that secure enclave to execute code safely. So maybe your leaf device doesn't have the hardware or the compute or the storage to run things in a secure way, but they can eventually leverage IoT Edge to run that secure code in a secure context in that enclaves and then retrieve an answer, which is being, vetted by the infrastructure on the IoT Edge device through IoT Edge runtime and the secure enclave. So we are embedding this kind of functionality in the IoT Edge scenario that actually will add a level of security that actually you cannot reach today with these tiny devices by nature. I mean, today, the main and safest way to secure your IoT Edge, your IoT devices in nature is actually to put them in a locked box so that people cannot access them.
No power.
Underground, covered with cement.
No power, not accessible. But now thinking about IoT Edge, providing a level of compute and the ability to run code in a safe and secure environment with enclaves, now you can enable new scenarios as well.
It's like the TPM. So the MX chip AZ3166 has the TPM module on there. And so when you provision it up, you can put your certificate, your encryption key into that trusted module. And then you just pass the content you want encrypted into that module, and it comes out without ever exposing to code that capability.
And there's a family of these secure modules. So TPM is one of them. On the MX chip dev kit, actually, it's a ST Micro ST Safe chip. There's DICE as well, which is another technology. There's several of them. One of the things that the secure enclave does, on under IoT Edge, is actually abstracting these various secure modules. So when you design your IoT Edge device, you can actually pick the secure module your choice, but your application and the modules running in IoT Edge will access them, transparently because we are abstracting, their way of interacting, their APIs, basically.
Sure. So you have a consistent sort of API footprint that you're interacting with, regardless of implementation.
Yep. Cool. Yeah, exactly. So security is another big scenario. So like IoT Edge, once again, to sum it up, so you have the disconnected scenario, you have the privacy scenario, and now you have the securing your IoT application all the way down to the devices.
That's right.
Sounds like they're pretty busy in the IoT Edge team.
Yeah.
Yes, kinda.
It's funny how important IoT is to Azure as well. I mean, it just plays to the scalable cloud so well and just really shows its value. Let me ask you another question around, just from the software developer's point of view, that decides that the individual items that are the individual devices, they want to use application insights. I mean, that's not unusual, right? They want to somehow send back telemetry that they've put into their application back through IoT Edge. How does IoT Edge help those developers?
So IoT Edge actually itself will have local storage for logs. So typically, if you're in an offline scenario, you can leverage IoT Edge to store logs and then synchronize them with the cloud. You are also able to have the logs from the cloud directly coming from the IoT Edge device. So you can basically track what's going on through IoT Hub, which actually will, by the way, allow you to do the same thing with the IoT devices that are not running IoT Edge. And then you have an interesting feature called distributed tracing that IoT Hub is supporting, which is an Azure functionality that will allow you to basically trace data from its inception or from its capture on an IoT device all the way up to the cloud. And you basically put a tag in the principle, the concept of it is putting a tag on that piece of data and then being able to track it at all its stages when it goes through Azure services. And each time it goes through an Azure service that supports distributed tracing, there's going to be a log into Azure Monitor that will actually allow you to see where the data has been and how it's been transformed. And so when you have an IoT application, or sometimes just other type of Azure application, they're very complex. You have various stages where data is captured, transformed, stored, analyzed, and then displayed, reused, shared, and so forth. And so when you have an IoT end-to-end application that captures a sensor data all the way up to triggering, I don't know, a ticket in some maintenance process in the business application,
right?
There's so many things that can go wrong in between to diagnose a problem in your application. So as a developer, you're able to implement a tracing that is very sophisticated of all the traffic, all the journey of that data to identify exactly where things went wrong.
Wow.
So that's super interesting. The other thing is the integration with the tooling developers, love and prefer. VS Code is actually the primary tool for IoT Edge. But we now have a very decent and almost on par development experience in Visual Studio. Proper. We have integration into Azure DevOps as well. So if you want to, create pipelines for your deployment and development of IoT Edge devices, you create new modules and you want to test them, you can use Azure DevOps and pipelines in order to do that. The IoT Edge tooling and IoT Hub itself are totally integrating to these tools for our developers to be, at home when they're developing on these IoT devices.
All these features, all this capability, all these use cases. That's the reason it's free. Boom! I don't know. What do you think, Darren? Is he telling the truth?
I think he is. I've seen a lot of it working. I tell you, it's amazing what you can produce in a short period of time. But to the point that you make, it's very easy to see how a business scenario could explode in complexity with all of these moving parts and everything coming together. So I think that sort of global monitoring solution is going to be key, because as we get these more sophisticated scenarios going on, and we have this huge volume of data that's flowing through, because it's all well and good when we're setting up, we've got one device and we've got one gateway and we've got one hub going through a single route in ASA, going out to an Azure function that's invoking a logic app or whatever. It's very easy to just trace that through. Multiply that up by 40 distributed sites, multiply that up by tens of thousands of sensors per site, and all of a sudden it's not the easy scenario that we see in our 101 lab.
Here's an architecture pro tip. Think this through before you do it.
And there's an easy way to approach the question as well, which is we are adding level of abstraction to the various services that we have for IoT. So we started by connecting devices securely, establishing communication. Now we added device twin on top to synchronize the state or invoking direct methods. On top of that, we've been adding IoT Edge being, the ability of running these workloads. We recently announced digital twins, which will allow you to create digital models of your IoT infrastructure plus spaces plus people and have a graph to access all that data, in context.
Not to be confused with device twin.
No, so device twin will contribute to a digital twin. So digital twin would be at the scale of a building or a ship or a car. The device twin is the individual piece within the digital twin that relates to the device itself, right? We have another feature called plug and play that we recently announced that will allow you to seamlessly connect the device, recognize the telemetry, the capability of the device itself, eventually having the device auto-declare its capabilities for then an application to immediately being able to display and use data from that device and eventually control it. All of that gets actually mixed and matched into IoT Central, which becomes your portal for IoT, where IoT Central is a one-click deploy and gives you all these functionality in a website that you don't need to develop and put together all these platform services. You can just leverage a built application that you add your devices or plug and play compatible. You will be able in the near future to integrate the digital twin models and rules into IoT Central and so forth. So you have different levels of approaching the problem, whether you go with IoT Central and it gives you what you need, or then you have to be more granular in the way you configure and customize these services, in which case you go with these PaaS services and implement IoT Hub and DPS and all of these services that can work together. IoT Edge as a story and has the Edge runtime will integrate into IoT Central. This is something that will be available real soon and will allow you to configure your Edge devices from an infrastructure that is like SaaS and no longer bricks of Legos that you have to aggregate yourself.
Yeah. Well, that's where it all started, right? Where we were just lining up all the bricks to get everything correct.
Yeah.
Now we're just trying to make it easy for the 80% use case that everybody goes through.
Exactly, and we're getting there and still enriching these PaaS services, but adding on top that layer with IoT Central. And at the end of the day, what we're going to also start doing, and this is the logical next step, which is offer customers the ability to build with IoT Central. So it's not going to be any longer about using IoT Central as it is, but enhancing the extensibility of IoT Central, opening up APIs. We announced that at Build recently, allowing you to customize the look and feel, and now integrate IoT Edge, integrate digital twins in the future, integrate with plug and play, all of these features and functionality for you to fully customize this IoT Central experience for your needs. So
this is really a broad set of topics for developers to kind of consume. And there's a good starting place and there's a bad starting place. What's the good starting place where a developer comes to you and says, where do I even begin to understand all of these things?
This is where I do my shameless plug for the IoT show, right?
That's right.
So I'm
just
running
hold up
that
the sign.
show, exactly, aka.ms/IoT show. So we run that show, Pamela Cortez and I. We have different types of shows. One is a shorter one, snackable, one topic, straight to the point, call to action to learn more. And then we have these deep dives that Pamela is running that are about taking an end-to-end scenario and for 45 minutes, 1 hour, dig into that scenario with some professionals, customers, and partners who are actually living the thing, suffering the pain and going through the experience of implementing IoT in real life. So that's the starting point. I recommend IoT show. Another place is IoT School. So we have a website that allows you to learn about IoT in a nice way, learning path and so on. We're working at making IoT School available through Microsoft Learn, which will give an even better experience going through that training content. Last but not least, we have a tech community. So if you go to aka.ms/IoT tech community, you can engage with your peers, ask questions, learn about the latest news and announcements. I have a weekly recap of what happened in IoT there that you can also, get all your links for your reading and watching and listening list for the week. So IoT Tech Community, IoT Show, IoT School.
Olivier, I tell you what, it's great to have somebody who's both knowledgeable and passionate about a topic. We definitely hit the nail on the head with you. Thanks for coming and talking to us about IoT Edge and IoT as a whole.
Thanks for having me, guys, and I'll talk to you soon.
Thanks.
Cheers.